For decades, Bill Nye, often referred to as the man of science, has captivated audiences by shedding light on the latest scientific breakthroughs and the mysteries they hold. His work has sparked curiosity about the final frontier, space, and its profound enigmas. Recently, Bill Nye has commented on the groundbreaking images captured by the James Webb Space Telescope, JWST, which have allowed humanity to peer more than 13 billion years into the past. These images have the potential to fundamentally reshape our understanding of the universe and challenge our perspective on life itself. The James Webb Space Telescope, a major milestone in astronomy, is revealing crucial information about distant planets, galaxies, and various celestial objects. It represents a monumental advancement in space exploration and continues the legacy of the Hubble Space Telescope. One of the central questions now is, what makes the JWST's images so extraordinary, and what insights does Bill Nye offer regarding them? The creation of the JWST was the result of many years of collaborative effort among NASA scientists and engineers. It launched on December 25, 2021, and its deployment proceeded smoothly over the following months. By June 2022, researchers had begun to detect thousands of previously unseen galaxies, some of which formed as early as 150 million, years before the oldest galaxies ever observed by Hubble. The telescope is capable of collecting enough light from celestial bodies such as exoplanets and stars to determine their compositions and trajectories across space. According to Bill Nye, this data is already providing detailed insight into the atmospheric makeup of planets that exist light years away from Earth. These findings offer the possibility of identifying worlds with the potential to support life. One iconic image captured by Hubble is the Pillars of Creation within the Eagle Nebula. While Hubble could view this formation in visible light, it couldn't fully reveal the star-forming activity within it. The JWST, however, using infrared imaging, has captured new stars in the early stages of development, called protostars, embedded within clouds of gas and dust. These clusters, each vastly larger than our solar system, appear as small red dots scattered across the image. These protostars are not yet undergoing hydrogen fusion. However, as more material accumulates in their cores, their density increases until a threshold is reached, triggering hydrogen burning. This process raises their core temperatures dramatically, up to around 2 million degrees Celsius. The different colors seen in the infrared images correspond to various infrared wavelengths, mostly invisible to the human eye. Blue tones indicate visible light, while redder hues signify infrared radiation. Because protostars emit light at wavelengths 6 times longer than what humans can see, the JWST's ability to detect them underscores its powerful infrared capabilities and offers critical insight into the formation of stars similar to our Sun. The discovery of exoplanets began in the 1990s, and today over 3,000 have been confirmed. However, only a small number have been directly imaged. Most exoplanets are located so far away that they can only be inferred by the dimming of their host star's light. In September of the previous year, the JWST captured its first direct image of an exoplanet named HIP 65426b, which had been identified in 2017. To observe this planet, scientists used coronagraphs to block light from the central star, along with 2 of the JWST's specialized cameras, a suite of filters, and other instruments. This planet is particularly suitable for direct imaging due to its brightness and extreme distance from its host star, about 100 times the distance between Earth and the Sun. HIP 65426b is a massive gas giant, nearly 12 times the size of Jupiter, and its properties make it ideal for infrared detection. The JWST has also captured images of the so-called Phantom Galaxy, or M74. Although this galaxy is faint to the naked eye, it becomes brilliantly detailed when photographed with infrared equipment. In visible light, M74 appears as a spiral structure of stars radiating from a central core. However, the JWST's infrared images reveal additional structures that resemble filaments of warm gas and dust stretching out from the galaxy's core. These new visuals highlight regions of active star formation within the spiral arms. To present a more complete picture, scientists combined images from both the Hubble and Webb telescopes to produce a composite that merges optical and infrared views. This composite was developed as part of the FANGS project, a European Space Agency initiative that collaborates with ground-based observatories to study 19 nearby galaxies using infrared data. The JWST's superior resolution at long wavelengths enables astronomers to pinpoint star-forming regions and estimate the mass and age of star clusters with remarkable accuracy. Another striking image taken in July of the previous year features the star known as Wolf-Rayet 140. This celestial body displays a distinctive pattern of concentric rings with slightly squared shapes. While diffraction patterns are a known imaging artifact, these unique rings are actual structural features resulting from the interaction between WR-140 and its smaller companion star. Wolf-Rayet stars are in the late stages of their life cycles and have already shed much of their hydrogen. These interactions between stellar winds are responsible for the odd geometric patterns observed. One of the JWST's most significant accomplishments to date is its detection of 4 ancient galaxies, believed to be among the oldest ever observed. In mid-December last year, researchers announced these galaxies had been identified at a time when the universe was only about 350 million years old, approximately 2% of its current age. These galaxies date back 13.4 billion years and were studied as part of the JADES JWST Advanced Deep Extragalactic Survey project. Scientists used the telescope's near-infrared spectrograph to analyze the redshift of these galaxies, a measure of how light stretches as the universe expands. The highest redshift detected was 13.2, confirming the galaxy's immense age and distance from Earth. The JWST has also turned its attention to an exoplanet orbiting a star in the Virgo constellation. Known as WASP-39b, this gas giant is located approximately 700 light-years away and orbits its star at a distance about 8 times closer than Mercury is to our Sun. Because of this proximity, the planet's atmosphere is extremely hot and dense. Scientists discovered that its atmosphere contains clouds rich in sulfur and silicates, including sulfur dioxide. Using 2 of the telescope's spectrographs, researchers were also able to detect carbon dioxide, revealing new details about the planet's atmospheric chemistry.